Hi everyone, this is Kalyan Kumar this side and welcome to Chemistry Universe. This is video number 7 and we are going to begin chemical properties from here. So this is for chemical properties, it is part 1 and in this one we are going to start the properties of amines, and one can guess sort of what could be the nature of those properties. Remember, nitrogen has an H, so it's an N being electronegative. H is reasonably acidic, and of course there is a lone pair on N that makes all amines basic, and therefore they can also act as nucleophiles. So we're going to check out these reactions in this particular video. So let's get on with it. Okay, so we are into part 7, chemical properties, acid, base, and nucleophilic ability. So the first one that we're going to talk about is reaction with acids. Now, obviously, nitrogen being basic, it can act as a base and therefore takes on acids, forms salts. And of course, when you heat these, the Cl minus will attack the R, and therefore ammonia will be released and you'll have nucleophilic substitution. So you have the instance of acting as a base and nucleophile at the same time. And if you were to do a sulfate with sulfuric acid, you're not going to get the nucleophilic attack because bisulfate ion is not nucleophilic at all, and therefore you'll only get the salt. And since there are 2H that H2SO4 can part with, 2 amines will react. Then of course reaction with alkyl halide, we have done this many times. R and H2 plus Rx, the R could be same or different, and you have nucleophilic substitution, you get secondary amine, another Rx, you get tertiary amine, another Rx, you get quaternary ammonium salt. Then we have acetylation, we have done something similar. R and H2 reacting with R prime COCl, if you remember, nucleophilic substitution, Cl will leave and RNH will take its place, and so HCl will be released. And if you were to do this with an anhydride, again the same thing will happen with the formation of a carboxylic acid. And we also have done the Schotten-Baumann reaction when we do phenols. And this was because whenever you have a nucleophile, but the acid halide happens to have a pH in it. If this is pH, then it is called the Schotten-Baumann reaction. All nucleophilic reaction on benzoyl chloride are called Schotten-Baumann reaction. And therefore, the same logic occurs here, and you're going to get this, and you get HCl released. Then of course, being RNH2H, you have acidic H, you can have reaction with active metals. So they form salts with metal, highly reactive metals like sodium, and with evolution of hydrogen gas. Of course, you get a hydrogen atom, and then hydrogen atoms combine to form hydrogen gas. Then another nucleophilic reaction we have done before is the reaction with Tilden's reagent. If you remember, Tilden's reagent is NOCl, N double bond OCl. And the N attacks the nitrogen, and the pi bond shifts to O, and you get this. And here you have the intramolecular proton exchange happening, but it is not going to happen that easily. So what happens is it simply releases an H plus to the solvent, and you get this. Now O minus, before the O minus comes back, that is of course an intramolecular proton exchange, and you get the OH. Nitrogen becomes minus. Now the nitrogen is the one that will release the Cl, and you are going to get something like this. And this will take the H plus from the solvent that gave away, so that you can get water. Then this will leave, and the Cl minus will attack the R. This will go out as nitrogen gas. Water is released. So you're going to get RCl, H2O, and N2. So you got to simply remember, of course, the mechanism is not required, but you need to remember the product of the Tilden's reagent is basically alkyl halide. Then of course comes a reaction with phosgene, poisonous gas, COCl2. So what do we have here? The nitrogen attacks. So I think, though the mechanism is not given, I think we can show you the mechanism. This is COCl. of course, it is COCl2. The lone pair attacks and the pi bond shifts to O. And then the pi bond comes back, the Cl leaves, and the Cl takes the H, and this goes here. So in the first instant, you'll get R and H, and you'll get a bond with a carbon, you'll get a double bond O, and you got a Cl again. So again, something similar happens. The lone pair comes and attacks. The Cl leaves, and the Cl takes the H, and this goes here. You'll get RNCO, which is nothing but alkyl isocyanate. If you remember, we used to do the hydrolysis of this to get primary amines. I remember Hoffman, bromomide, and all those reactions. And then comes reaction with aldehydes. Pretty simple. You get amine or Schiff's base. We already done this. So amine or Schiff's base or anyls. In this particular case, you can call them as anyls also. And that sort of takes care of the basic reactions of acid, base, and nucleophile. So with that, we come to the end of this video, and we're going to continue with the properties of amines in the future videos. Till then, have a nice day. Goodbye, and thank you for watching this.